Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm still not. Nothing's changed. So,
And welcome to Chemistry for Your Life,
the podcast where we help you understand the chemistry of everyday life.
Hey, Jam, remember that time you talked about how you boiled a pot of water forever and it never boiled and science was broken?
Yeah, I remember that. It still frustrates me. It still gets under my skin somehow. It's almost like that pot is still like, remember when I got the best of you?
Well, this week I'm going to teach you about that.
Oh, interesting.
Yeah, I'm going to tell you what you did wrong.
Okay.
And probably why it took so long.
So what it sounds like you're saying is that science wasn't out to get me. It's that I made a mistake, which I don't appreciate because I'm pretty sure science was out to get me and it wasn't my fault. And it was not my fault.
There are a lot of chemists I know who would tell you that sometimes science just is not for you. And you do the same thing. You say, I did the same thing the exact same way and it didn't work this time. But that is usually not 100% true. Usually you did not do something exactly the same way.
Yeah.
But you're not alone. And chemists around the world agree. Well, okay, but so I'm going to teach you about that.
Okay.
But also in the context of that, we're going to talk about why people salt roads when it gets cold.
Oh, okay. Interesting.
And then you're going to tell me all about what you learned.
Okay, deal. I'm in.
Are you
Sign me up.
excited?
Yeah, I'm very excited.
You're finally going to be able to get the better of that pot back?
Yeah, I think so. And also, I could reiterate that story a little bit later, but I was in a kitchen I was not familiar with, using things I was not familiar with. So it's like I was out of my element in more ways than one.
Okay, so before we do all of that, let's talk about how your week was and how my week was. Let's catch up.
Let's do it.
We're kind of on a different schedule today. Normally we go in the mornings to record, and it's late in an afternoon.
Yeah, normally it's early in the week too. So it's like, what's happening?
It's been nearly 2 weeks since the last time we saw each other. One and a half.
Yeah.
A lot. So how was it?
It's been good. I've been, I think I mentioned last time we recorded that I've been kind of getting into a more diligent job searching mode. And so that's been interesting. It's been, it's hard. Everybody's had that experience. But it's been pretty cool this week. I have, there's a couple jobs I'm pretty interested in, and I've gotten some serious assistance and advice and wisdom on my resume and cover letter strategy and all that stuff. I haven't done that a ton. So it was like, I had a way I was kind of doing it, but got a lot of help from one of our friends.
Nice.
And now I feel a lot better about stuff. So that's... Can
I ask which one of our friends? Can we give him a shout out?
Let's give him... Yeah, it's Vianette. Let's give her a shout out.
Vianette, hey, friend of the show.
Yeah, she's a master. So I feel great. And obviously it'd be cool if I had more news to share. Like, it happened and then immediately I got like 16 job offers and or something like that. But this is just, partway through the story. But yeah, so that's sort of a little update.
Nice. That's exciting.
Yeah.
Vianette, just for the listeners at home, was heartbroken that she did not win a shirt
on
her giveaway. So it's really nice of her to overcome that hurt and to help you out.
Yeah. And she's the one who asked the cool question about told us about the plant in Peru.
Yeah.
So, yep.
She's a scientist at heart, even though she's not in profession.
Yeah, you could tell. It comes through.
Yeah,
she can't hide
does. Okay, well, my week, not that you asked.
I did, sorry. So how about your week?
My week? School started back up, which is why we're on the weird schedule.
Yes.
Our new normal schedule.
Mm-hmm.
And at first, I thought, I've got this, like, I can totally handle the semester. And then somewhere around Wednesday afternoon, it felt suddenly as if I couldn't handle anything, and I was very overwhelmed. I just had a lot of stuff happen one right after another, but there was little happy things that happened throughout the week that kind of made it better. So on Wednesday afternoon, after everyone who could have possibly helped me with this left, I locked my keys in my office, which was horrible, but I did grab my car keys, so at least I could go home. And I had my computer, so I could still work even though everyone was gone. So it was like little things that were happy. Or I came home and I saw these dishes that I really needed to clean. And I'd been saying I was going to clean for like 2 days. And I was like, I just can't. And my sweet roommate cleaned them for me and shared her Chick-fil-A cookie with me.
Aww.
So little small things that have made things a little bit better.
Yes. Yeah.
Makes
a huge difference.
It does.
Yeah.
It could be so much worse, but you have this one thing to cling on to.
Yeah.
And Labor Day weekend coming up. So I get to go out of town, and then I have all day Monday to do homework and catch up. And it's like I get to go out of town with no negative ramifications.
Yeah.
So that's kind of nice. So it's getting better. It was just a lot with teaching and taking classes and stuff.
Yeah.
So yeah, that was my week. We both had some intense weeks.
Seriously. Yeah.
Getting things done, back into the swing of things.
Yep.
So
yeah, it feels good to get stuff done.
It does feel good to get stuff done. Are you ready to get stuff done in terms of learning about chemistry?
Yes.
Did you see that smooth transition?
Very smooth, yeah. And get stuff done in terms of not letting science get the better of me next time around.
Yeah.
Hopefully.
Well, let me ask you this.
Okay.
Can you describe what you did to that pot? Was it a large pot?
Mm-hmm.
You said you put salt in it. How much salt did you put in it? Let's just talk about it.
Okay. So, a little context too. I was, just because, the non-science people are going to want to know, like, what was he making? So I was trying to make.
Are they?
Yeah. I mean, they're like, it helps have the story around it. So it's like to know.
Give the story.
So we were at my uncle's lake house. And so using pots and pans and stoves and stuff like that I was not used to using.
Yeah, that's fair.
I was making chicken scampi, which is my wife's like fave. And I had made it before just for like us here at the house. Mm-hmm. And so I was making a larger scale version of it also. Mm-hmm. So I was like, all right, boom, biggest pot I can find. Let's do this. And also we had like a lot of things to, the stove was going to be a happening place, like a few different things to make. So we like one of them, we had to also grill some chicken at the same time and stuff like that. So what I did was got the biggest pot I possibly could.
Yes.
This big pot I found also had like the exact same shape, a colander inside
one of those
it.
strainers that goes inside of it. Yeah.
So I had one of those. So filled that sucker up with water. Then I put in some salt, just poured a little bit in there.
Right.
And I put in some oil, olive oil, and turned the burner up to the highest I could.
Okay. Did it ever boil?
Not then. We actually started over at one point after like I think like at least 30 minutes seriously of it trying to boil. Maybe more. I don't know. I really don't know. But it didn't. And then we just started over. I can't remember all the things we changed, but we just literally dumped that pot.
You dumped the pot?
Mm-hmm. We were like, this is cursed.
Did the second time, did it boil?
Mm-hmm. It did.
Much faster?
Uh-huh.
Did you add the same stuff to it?
I can't remember, but I would guess that we did, but I could be wrong.
Okay. Well, I'm going to tell you what I think you did wrong.
Okay.
Have you ever heard anything happens to water when you add salt to it and you're trying to boil it?
No, I haven't. I only did that because we were going to make pasta for a taste. So I don't.
Okay.
I didn't do that for any other.
So actually, a lot of people add salt to water because they believe that it will make the water boil faster. So I learned the truth about this situation when I was in general chemistry, maybe even high school chemistry, like 2007.
Yeah.
And in the last 12 years, I can't tell you how many people have told me they add salt to the water to make it boil faster.
That's crazy. I've never heard that, but maybe it just hasn't stuck in my memory. Like maybe I just don't remember it, but people have said that. I don't know.
Well, I probably only remember it because that's wrong. I'm like, no, that's not what happens. So what happens when you add salt to water is salt dissolves in water. So it forms a solution. That's different than if you were to add, say, sand to water and it just sinks to the bottom. Salt will actually dissolve into the water, right?
Yeah. Yep.
So when you have that solution, the salt particles are dissolved all throughout the water. Now then, let's think about water vapor and boiling water. We talked about this a few episodes ago. When water boils, the water vapor escapes from the top layer of water.
Yeah.
So there's water molecules all on the top of that pot full of water. So that is the layer that's most quickly going to escape and turn into water vapor gas.
Yeah.
Okay. If you have salt distributed throughout that, you have less water particles, less molecules of water on the top layer.
Okay.
Okay.
Interesting.
So say this is not...
Basically, are you saying that there's less molecules because now we've added something else?
Yes.
Okay.
So imagine a pure water, no salt, say this is just like not even right at all, but say there's 100 water molecules on the top layer. Then you add salt in, and now there's maybe only room for 75 or 50 water molecules because of the salt that's dissolved in there is taking up some of the space on that top layer.
Got it. Okay.
Does that make sense?
Yes, it does.
So then there's, say, this is just an estimate, but only a fraction, like maybe 75% as much water vapor as there is in the pure water pot.
Okay, got it.
Okay. Now you tell me what I just said. You look very confused.
I was really trying to I was like, this is going to seem too simple, but I need to make sure that I'm listening.
Okay.
So when you dissolve salt into water, it's not just water anymore. It's not just H2O.
Correct.
You've added stuff that's dissolved into it. And so now if you take even if you take any sample at all, especially from the top where it's trying to turn into vapor, if you just take a small sample of that and you look at it, it's going to be only a certain percentage water now and a certain percentage of the salt stuff now. So it's just not, you just complicated it more than just like, oh, there's some salt in there now on the like molecular level. It's not just one thing anymore. Or I guess it was two things. It was hydrogen and oxygen, but it's not like, it's more than just the fact that it'll taste salty now. Right.
So you've changed it on a molecular level. So you don't just have H2O is considered one molecule. It's made up of 3 parts, but it's one molecule.
Okay.
So it's not just one type of molecule all the way throughout. It's one type of molecule mixed in with dissolved salt all around.
Yeah.
So do you remember the definition of boiling point?
I think I do. Okay. I think boiling point is the point.
This is a good test of how much recall you have. How much of this is sticking in your mind?
I'm nervous now. The point when vapor pressure reaches the same or reaches or like overcomes the atmospheric pressure.
You did it. That's it.
Nailed it.
So that is key to what's about to happen.
Do we do grades in this podcast? Do I get a grade?
Yeah, that was an A. You got the...
Excellent. Okay, cool.
100% correct.
Perfect. Okay, great.
So that's key to what happens then when you add salt to water. Because if you've added salt to water, you now have only a fraction as much water that can turn into vapor compared to pure water.
Got it. Yes.
So if you heat those two to the same temperature, you'll have more water vapor in the pure water than you will in the salty water.
Right.
So that means you have to heat it higher to get the same amount of vapor pressure.
Yes.
So that means you've increased the boiling point of the water simply by adding salt.
Increased the boiling point. I didn't even think about it like that. But like if you put a thermometer in there, it could be like 215 degrees Fahrenheit or something like that. Just something a little bit higher.
Yes.
Before it actually starts showing that it's boiling.
Yes.
Whoa.
And there is a name for that kind of property. It doesn't matter what substance you put in there, actually. It matters that it's a solution, so it truly dissolves in the water, and how much you put in there.
Yeah.
So if you put a little bit of salt in there, like a pinch of salt to increase saltiness when you're making that pasta, it would not have increased the boiling point very much.
Okay.
If you put a handful of salt in there when you're making that pasta, it would have increased the boiling point significantly. If you put sugar in there, instead of salt, it would have the same effect. Sugar also increases the boiling point.
Interesting.
Yes. So the name for that is something called, this is a big science jargony word.
Okay.
Just so you can know what it's called.
Yeah.
Colligative properties.
Whoa.
It's a big word. It basically means a property that depends on how much you put in rather than what you put in. The mass you're putting in determines how much the boiling point increases rather than what you're putting in.
Yeah. So it's not like salt has this unique property that like basically thwarts water's efforts to boil. Like that. It's it's like, no. You added something to it.
Right.
And because of that, now you have to have a hotter, it has to get hotter before it'll ever boil.
Yes.
Because it's not just water anymore.
So I suspect that is what happened to you. I think you added enough salt to where you accidentally made the boiling point go up quite a bit, and it was just taking a long time to get there.
Yeah.
Now, this is where people, I think, get the idea that it will boil faster is because it's hotter. It could cook your food faster.
So
if you had stuck with it and it boiled eventually, I think your pasta would have cooked faster in that pot than in your start over pot where you probably didn't put as much salt.
Interesting. And also then it brings up the question of, is it even important that it actually starts to boil? If the water was actually already like 212 or whatever, I could have done that pasta already in there. It's just like, it's a nice visual indicator like, oh, this water's hot now. It's hot enough now. Make sure it gets the bubble deal going on.
Yeah.
It's like, we could probably cook pasta at less than 212.
Yes.
Interesting. Wow.
So, or
that really
at
has haunted
212,
me.
even when it's not boiling.
Right. Yeah.
So there's another side to this.
Okay.
And I think we'll go more into this later on. So we haven't talked about melting point at all. But adding salt or sugar or anything else with that type of colligative properties to water will also, in addition to increasing the boiling point, decreases the melting point.
Oh, okay.
So that means you throw some salt on some really cold water, and if it gets down to, say, freezing temperature on the road, it won't freeze. So that is why people salt roads when it's going to freeze.
Got it. Okay, cool. So then basically you'd be saying like, just as a like test or whatever, these numbers aren't accurate, but say you put some salt on a road, the road would have to get then like maybe like 28 degrees to freeze instead of like 32. Like
Right.
it just kind of gives you an extra amount of room in terms of degrees.
And
some amount.
if you put more on, it'll go even lower.
Okay.
So I read some things get all the way as low as 6 degrees Fahrenheit if you put enough salt. I don't know because we probably don't ever get that cold here.
Yeah.
But so you can put more and it will have a greater impact of depending on your water too.
Yeah. Interesting.
Salt. But that means you could also sugar roads.
Yeah.
I think about that all the time. I'm like, why did they pick salt to put on roads instead of sugar to put on roads?
Which one's cheaper or which one's less harmful to like nature?
I have no idea. I just
like,
imagine how happy children would be if you sugared roads and then it snowed
it'd
and
be
then
so
it's like
sticky, though.
sugar. Oh, yeah, I bet that's like because it's sticky.
Yeah, that's a good. Yeah.
I just imagine a dream world in which we sugar roads and then somehow it's not dirty and like kids can just scoop it up on top of their snow and eat it or
Yeah,
something.
if you make snow ice cream, it's like, oh, hey, it's already sweet.
Yeah.
Is there a science word for sticky?
I don't know.
All right.
Sticky. I mean, there's viscous.
Which I like
That's
that word a lot.
thickness.
Yeah.
I don't think there is a science word for sticky. Okay, if there's any scientists out there listening and you know the scientific term for sticky, I think that might be a biologist. I feel like biologists would maybe know that better than chemists. Then just write in, email us, tweet at us at ChemFreeLife on all platforms. Please, please, please.
That weird sudden question is also my official submission of a topic. So if someone reaches out to you or whatever, that's like, yeah.
Okay. So that's everything I have for you today.
People thought, my whole family thought, it wasn't boiling because I put there was this colander thing in there that was like the exact same shape of the pot. That was the reason, that somehow it was like preventing the water temperature from getting high enough, something like that, or something like, I don't know. And so there was like a collective, like I was the only one who didn't really believe it, but also because I was in charge of dinner that night and I was kind of being stubborn.
You're being stubborn, yeah. I've
everybody was
never
like,
known you to be stubborn, Jam.
Yeah, never. Yeah, and I wouldn't start now, okay? So everybody thought that was the reason. And so when we did take that out and start the water over, like we totally dumped the pot out and everything. And then it actually did boil, but we could have put less salt in, or maybe I forgot to put salt in at all, period. Who knows?
Because you were so flustered.
Yep.
Well, my scientific opinion is that colander, was it one of those thin metal ones?
Yeah, it was
that
not.
Comes inside the...
Yeah, it was not super thick.
Yeah, that probably did nothing. It was maybe one more barrier of something that would accept heat, but then it would just probably, because metal has a very low specific heat, so it would probably be taking in and releasing heat very quickly.
Yeah.
So you can tell your whole family that you were right and a scientist told you so.
Wow.
And that probably the problem was the amount of salt you put in, which means it was still your fault, though.
Yeah, but you hear that, family? It was my fault, but not in the way you guys thought, all right? I found a different way for it to be my fault than any of y'all ever would have predicted, all right? So take that and shove it.
Now that you've been triumphant, can you explain back to me
Yes.
what happened on a molecular level when you add salt to water that's trying to boil?
So when you've got just water in your pot, it's just one type of molecule, H2O. But when you add salt, you are adding stuff into it. So then if you take any amount or whatever, there's more than just water molecules there. So those molecules that are trying to turn into vapor, now there's other stuff with them as well. And so the vapor pressure, it's trying to like increase while more and more water is trying to turn into vapor. Now more of it has to happen for it to get above the atmospheric pressure to actually get to boil, something like that.
That was close. It's not that more of it has to turn into vapor, because if it's under exactly the same conditions, the vapor pressure would need to be the same amount for both, because it needs to meet atmospheric pressure for it to start boiling.
Yeah.
So if your atmospheric pressure is the same for your pot with no salt and your pot with salt, then the same amount of water needs to turn into vapor. But if you have salt there, it's blocking some of the water molecules from turning into vapor almost.
Got it.
That's a sort of like a football player blocking you from getting into water.
I get that analogy for sure. Love football.
Jam hates sports.
So it blocks it, but not like it's actively blocking it. It's just that because it exists and because it's there, it's in the way.
Right.
Got it.
It's in the way. And so at the same temperature, all things being exactly equal, these two pots being the same temperature, under the same atmospheric pressure, everything exactly the same. The one without salt just has more vapor because it's not being blocked or impeded in any way. So it just has to get a little bit hotter to get as much vapor.
Got it.
Just to get around the salt, sort of.
Yeah.
Just less water molecules available to turn in to vapor.
Yeah. Okay. Got it.
You tracking with me?
I am. And it's not because salt is salt and because it has something about it that makes it that way. It's because it could be sugar or it could be something else too. Just having something else in there that would do the same thing that would kind of block it.
Right.
Would cause the same problem.
Yes, and that's called colligative properties. When you it doesn't matter what you dissolve in there, but anything you dissolve in there is going to change the property of something. Colligative properties.
Sweet. I like that word. I want to find a way to use it naturally.
Well, you could just be talking to someone when they're cooking and say, hey, you're making a solution with your water and your salt.
Yeah.
And the properties of that solution depend on how much salt you put in there, and that's called colligative properties.
And I'd be like, listen, you're going to collig up your
collig
water.
up. No.
The water you're trying to boil right now, so you better be careful.
You can warn people. And it's crazy how many people think it just makes the water boil faster.
Yeah.
Which we learned. That's what putting a lid on it does.
Yeah.
So your options are make the water boil hotter, add some salt.
Yeah.
Make the water boil faster, put a lid on it.
Yeah.
That day you could have not added salt, or you could have thrown a lid on there, and either one would have helped you out.
Or both, and I would have been unstoppable.
Both, and it wouldn't have had anything to do with the colander inside.
Man, sweet. I will not make that mistake ever again.
Now you know.
So Melissa and I have a lot of ideas, just like this one, which I didn't even know we were going to do today, for topics of chemistry in everyday life. But we also want to hear from you. So if you have questions or ideas, you can reach out to us on Gmail or Twitter, Instagram, Facebook, at Chem for Your Life. That's Chem, F-O-R, Your Life, to share thoughts and ideas. And if you enjoy this podcast, you can subscribe on your favorite podcast app. If you really like it, you can write a review on Apple Podcasts. That helps us to be able to share chemistry with even more people.
Thanks, you guys, so much for listening to today's episode. This episode of Chemistry for Your Life was created by Melissa Collini and Jam Robinson. Jam Robinson is our producer, and we'd like to give a special thanks to A. Kiwasong and A. Collini, who reviewed this episode.